Since time immemorial, humanity has gazed at the stars and pondered the vast mysteries of the cosmos. We have questioned our place in the universe, the nature of reality, and the elusive possibility of other worlds. Among these enduring enigmas, the concepts of time travel and parallel universes stand out as particularly tantalizing. The idea of journeying through time, of witnessing historical events firsthand, or even altering the course of history, has captivated our imaginations for centuries. Equally captivating is the notion of parallel universes, alternate realities where different versions of ourselves might exist, where different choices were made, and where history unfolded along divergent paths. These concepts, once relegated to the realm of science fiction, have increasingly become topics of serious scientific inquiry, blurring the lines between fantasy and reality. The allure of time travel and parallel universes lies not only in their potential to unlock the secrets of the universe, but also in their profound implications for our understanding of ourselves and our place in the cosmos. If time travel were possible, it would challenge our fundamental assumptions about cause and effect, free will, and the very nature of time itself. The existence of parallel universes would suggest that our reality is but one of countless possibilities, raising profound questions about the nature of identity, choice, and the meaning of existence itself. In the early 20th century, Albert Einstein revolutionized our understanding of space and time with his groundbreaking theories of special and general relativity. Einstein's theories, which have been repeatedly confirmed by experimental observations, provide the theoretical framework for the possibility of time travel, at least in a limited sense. Special relativity, published in 1905, introduced the concept of time dilation, which states that time is not absolute but is relative to the observer's frame of reference. One of the most startling implications of special relativity is that time slows down for objects in motion relative to a stationary observer. This effect, known as time dilation, becomes more pronounced as an object approaches the speed of light. General relativity, published in 1915, extended special relativity to include gravity. General relativity describes gravity not as a force but as a curvature of space-time caused by the presence of mass and energy. According to general relativity, massive objects like stars and black holes warp the fabric of space-time, causing time to slow down in their vicinity. Einstein's theories suggest that time travel into the future is theoretically possible, albeit incredibly challenging to achieve in practice. By traveling at speeds approaching the speed of light or by spending time in extremely strong gravitational fields, it might be possible to experience time dilation, effectively fast-forwarding into the future. However, time travel to the past remains a much more elusive and controversial concept, fraught with theoretical paradoxes and seemingly insurmountable technological hurdles. While Einstein's theories provide the theoretical basis for time dilation, they do not explicitly prohibit the possibility of traveling backward in time. However, such journeys would require bending the fabric of space-time to an extreme degree, creating shortcuts or loops that would allow travelers to bypass the linear flow of time as we experience it. One hypothetical concept that has captured the imagination of physicists and science fiction writers alike is the wormhole. Wormholes, also known as Einstein-Rosen bridges, are theoretical tunnels that connect two distant points in space-time. These tunnels, if they exist, could potentially allow for instantaneous travel between vast cosmic distances, or even between different points in time. Another speculative concept that has been proposed as a means of achieving faster-than-light travel and by extension time travel is the warp drive. A warp drive, as envisioned by physicist Miguel Alcubierre, would involve compressing the fabric of spacetime in front of a spacecraft while expanding it behind, effectively creating a warp bubble that would propel the spacecraft through spacetime at speeds exceeding the speed of light. It is important to note that both wormholes and warp drives remain highly speculative concepts, with no observational evidence to support their existence. Moreover, even if these exotic phenomena were possible, the technological challenges involved in harnessing them for time travel would be immense, potentially requiring energy levels far beyond anything achievable with our current understanding of physics. Section 4, The Philadelphia Experiment, Fact or Fiction. The allure of time travel has spawned countless stories, legends, and urban myths. One such tale that has captivated the public imagination for decades is the Philadelphia experiment, a purported military experiment alleged to have taken place in 1943. According to the most common version of the story, the U.S. Navy conducted a secret experiment at the Philadelphia Naval Shipyard, attempting to render the destroyer USS Eldridge invisible to enemy radar. The experiment allegedly involved using powerful electromagnetic fields to distort space-time around the ship. The story goes on to claim that the experiment went horribly wrong, causing the Eldridge to not only become invisible but also to teleport from Philadelphia to Norfolk, Virginia, and back again in a matter of minutes. Some accounts even suggest that the experiment had disastrous effects on the crew, with some sailors allegedly fused to the ship's metal bulkheads or suffering from severe mental trauma. The Philadelphia experiment has been widely debunked by scientists and historians as a hoax. No credible evidence has ever been found to support the claims, and the U.S. Navy has consistently denied that any such experiment ever took place. Nevertheless, the story persists in popular culture, fueled by books, movies, and television shows that have embroidered the original tale with even more fantastical elements. Section 5. Time Slips and Echoes. Glimpses of Other Times. While the Philadelphia experiment is widely regarded as a fabrication, there are numerous anecdotal accounts of individuals who claim to have experienced strange and unexplained phenomena that suggest the possibility of time slips or echoes, fleeting glimpses of other times bleeding through into our own. One well-known example is the case of Rudolph Fentz, a man who allegedly appeared in New York City in 1950, wearing clothing that was out of style by several decades. According to the story, Fentz carried identification dating back to the late 19th century and claimed to have no memory of how he arrived in 1950. He subsequently disappeared from a hospital room, leaving behind his belongings and a mystery that has never been solved. Another intriguing account involves the Moberly-Jourdain incident, named after two Oxford academics who claimed to have experienced a time slip while visiting the Palace of Versailles in 1901. The women reported seeing people dressed in 18th century attire, and even encountering Marie Antoinette sketching in the gardens. These anecdotal accounts, while often compelling, lack verifiable evidence and are often dismissed as hoaxes, misinterpretations, or simply the products of overactive imaginations. However, some researchers believe that these stories, along with other unexplained phenomena like déjà vu and precognitive dreams, might provide tantalizing hints about the true nature of time and the possibility of temporal anomalies.